Something like 90% of all cancer-related deaths, they aren't actually caused by the first tumor. They're caused by its spread, a process we call metastasis. So today we're diving into this really fascinating strategy pioneered by Doctors Rath and Pauling. It asks a totally different question. What if, instead of just trying to destroy cancer, we could just contain it, trap it, before it ever gets the chance to escape? So that brings us to the most fundamental question of all, right? How does cancer actually do that? How does a tumor that starts in one place manage to break out, travel, and then set up shop somewhere totally new in the body? Well, the way the source materials put it is pretty powerful. They describe it as a microscopic prison break. And I think that's the perfect analogy. This isn't just some passive disease process. No, it's an active, physical breakout. A group of malignant cells basically decides, we're out of here, and starts planning an escape. Okay, so to really understand a prison break, you first got to understand the prison, right? It turns out our bodies have this incredible natural containment system. Think of it like a biological fortress wall that's designed to keep all our cells exactly where they belong. And this fortress wall, it has a technical name, the extracellular matrix, or ECM. It's this dense web of tissue that you see here, basically the biological glue that holds our entire body together. It's made mostly of a protein called collagen. And get this, the sources point out that gram for gram, some types of collagen fibers are actually stronger than steel. That's a serious wall. But here's the catch. Those rogue cancer cells, they're not just trying to punch through that steel wall. No, they're much smarter than that. They've developed a specialized weapon that's designed to literally dissolve the wall from the inside out. And their breakout plan is just ruthlessly efficient. Step 1. The cancer cells pump out these very specific tissue-dissolving enzymes. Step 2, those enzymes get to work, just digesting and clearing a path through that collagen fortress. And then, step 3, once the coast is clear, the cells can invade, get into superhighways like our bloodstream, and travel just about anywhere. So what is this secret weapon? Well, the sources identify a main culprit, a class of enzymes called hyaluronidase. You can think of this as the cancer cell's chemical key. It's the acid that it uses to melt the steel bars of its collagen prison, allowing it to finally break free and metastasize. So once researchers like Doctors Matthias Rath and Linus Pauling really understood this breakout mechanism, it led them to ask a completely different question. They thought, okay, instead of just attacking the prisoners, what if we could reinforce the prison walls and at the same time disable their tools? And that idea led to this really innovative two-part defense strategy. And this chart really lays out that shift in thinking. The conventional approach, it focuses almost entirely on attacking the cancer cells directly. But the Rath/Pauling protocol, which came out of a 15-year landmark study, does something different. Its main goal is to strengthen the body's own connective tissue, to build up that collagen fortress, and physically wall off the tumor using a specific team of micronutrients. So the strategy is really a 1-2 punch. The whole goal is to do two things at the exact same time. 1, rebuild and reinforce that fortress wall to make it stronger, and 2, neutralize the chemical weapon, those enzymes, that the cancer cells are using to try and break it down. So how in the world do you do that? Well, the research points to a very specific defense team of 4 key micronutrients. Each one has a very specific job to do. So let's meet the team. First up, you've got the construction crew. These are the nutrients responsible for rebuilding the fortress wall. We're talking about vitamin C, specifically a form called ascorbyl palmitate, which basically tells the body, hey, make more collagen. And it works hand in hand with 2 amino acids, L-lysine and L-proline. These two are the literal bricks and mortar, the raw materials the body uses to build new, strong, and stable collagen fibers. Okay, next up, we've got the security team. These are the agents that go in and neutralize the enemy's weapon. And here's where it gets really clever. L-lysine, it plays a double role. Not only is it a building block, but the sources say it also acts like a shield. It actually attaches to the collagen and physically blocks the spots where those dissolving enzymes would try to latch on. And it's joined by EGCG, a compound from green tea, which is like a heat-seeking missile that hunts down and deactivates the hyaluronidase enzymes directly. So let's just zero in on that EGCG for a second. The sources really highlight this stuff. It's the most powerful and abundant polyphenol you can find in green tea. And its whole job in this strategy is crystal clear. It's a potent enzyme inhibitor. It's one of the key players responsible for disarming the cancer's breakout tools. So what happens when you put it all together? You've got the construction crew rebuilding the wall, and you've got the security team disarming the breakout tools, all at the same time. Well, the outcome, according to all this research, is simple: containment. This is where the synergy is just so powerful. You're slowing down the breakout by taking away the enzymes, and you're making the wall tougher to breach by strengthening the collagen. When you do both of those things at once, you get this amazing effect where the tumor essentially becomes trapped. It's walled in by healthy, resilient tissue that it just can't dissolve anymore. And look, this isn't just some cool idea on paper. That big 15-year study from doctors Rath and Pauling, they tested this exact nutrient combination on all kinds of cancer cells. And as you can see from this list, it proved effective at blocking the invasion of so many common and aggressive cancers. We're talking melanoma, breast, prostate, lung cancer, and more. There's a quote from one of the source texts that I think just nails it. It says, "Lysine is effectively the lock on the garage door." It's such a simple but perfect image. If the tumor is a car in the garage and the collagen wall is the garage door, lysine is the lock that stops those enzymes from being able to open it up and let the cancer out. And that really brings us to the final big idea. When you remember that it's the spread of cancer that's responsible for most of the deaths, it forces you to ask a pretty profound question. In this whole fight against cancer, could strategies for containment, for just locking that garage door, be every bit as crucial as the search for an outright cure? It's a shift in perspective that totally redefines what winning against cancer could actually look like.